Hi, how are you? Okay, we are going to, let's see, we are talking about cell potential and free energy. Yeah, that's what we're talking about, cell potential and free energy. So excited, so excited. All right. I did post a couple questions that we'll go over. Here we go. So let us get started, shall we? So if we are going to discuss cell potential, right, and free energy, what do we need to say? Well, this is our E cell and delta G, right? E cell and delta G. Well, what do we know? We know a few things. We know that we have a positive E cell, we have a negative delta G, we have a negative E cell, we have a positive delta G, right? We know that. It is also true that delta G standard equals negative NFE standard. Standard in electrochemistry is 1.0 atmospheres. It is 1.0 molar, and the temperature is now 25 degrees Celsius. So confusing because they just like up and changed it on you, right? But N here is number moles of electrons transferred. Okay. And F is Faraday's constant. That is 96485. Some people say 96500. Just use whatever you're given. Coulombs. Oh, crap. Oh, never mind. Coulombs. I just answered it and then I just hung up. I can't make this video again. I just got to the very end and made a stupid mistake and I had to stop. Coulombs per mole of electrons. E here is our E cell. E cell. He just called me again. E cell. Standard. Okay? Standard. Okay, so it's simple. It's real simple. And this is in volts, right? And I have it written up here that a volt, 1 volt, is equal to a joule per coulomb. So you'll see how the units work. Given the electrochemical reaction shown below, what is the standard free energy change delta G if, well, and you can kind of think GNRF. GNRF. That's one way I memorize it. I'm so true. I'm so honest. I really do. So we need to solve for delta G standard. I need my number of moles of electrons. We'll look here, Mg to Mg, 2 plus is 2. Zn to Zn, 2 plus, we see that's 2. So therefore, we've got negative 2 moles of electrons. I've got Faraday's constant, 96485 coulombs per mole electrons. And then our E cell is 1.61. What was that? Joules per coulomb. Okay. So on negative 2 times 96485 times 1.61 equals negative 3.11 times 10. I was just sitting here thinking about that phone call a minute ago. How I was like, I made a couple of stupid mistakes in this video. Okay, so notice here you've got delta G standard. It's negative, which is good. We expected that. It is in joules. Remember that we often have delta G's in kilojoules. So, right, if we were to divide that by joules, and we would have our kilojoules, Oops. And I think it's kind of important to notice that a little bit. Just, you really want to pay attention to units here. Guys, like, for example, in the video I showed you a minute ago, or I messed up, and that's per mole of this reaction, okay? The way it's written, okay? The way I caught my mistake, and it was a stupid mistake, was I was paying attention to my units, and I realized one didn't cancel, and I was like, I forgot to write the stupid temperature down. So pay attention to your units. The oxidation of hydrogen by oxygen is one of the most used reactions in fuel cell technology. We have a delta G of negative 474. Notice that's kilojoules. It's per mole of the reaction as written. What is the standard cell potential? Delta G standard equals negative NFE. So we need our E cell. All right. This is in 474 kilojoules. And our E cell is typically in joules per, right? It's in volts, which is a joule per coulomb. So we should probably go ahead and work with joules so that we got that. And that's going to be negative 4.74 times 10 to the 5th joules. And that is per mole of the reaction, guys. Okay. So also, and so delta G is negative 4.74 times 10 to the 5th joules per mole of the reaction equals, we need our number of moles of electrons. Well, 2H2 plus O2 yields 2H2O. 0, 0, negative 1 makes an over, positive 1, positive 4, negative 2, negative 4. So I am going from 0, I have a total of 4 electrons being transferred. So I've got negative 4 moles of electrons, Faraday 96485 coulombs per mole electrons, and then E cell here is what I'm actually solving for. It needs to be positive, it should be. So on negative 4.74 second E, clear, mess that up, second E, 5 divided by parentheses negative 4 times 96485 close parentheses equals 1.23. It is positive. It's a normal value for voltage. That's good. Notice I've got my joules. These cancel per coulomb, and that is a volt. All right. Lastly, Gibbs free energy and the equilibrium constants. Electrochemical cell potentials can be used to determine equilibrium constants that would otherwise be difficult to determine because concentrations are small. Okay, so you can't calculate the concentration, but we can use cell potentials to figure out what K would be. So standard E cell is given to us at 0.0218 volts. That is 0.0218 joules per coulomb, right? What is K equals question mark? All right, well, I know that, remember that Ratley equation, delta G equals negative RT ln K? And I know that delta G equals negative NFE. So I'm going to first solve for delta G, and then I'm going to plug it in here and solve for K, okay? All right, so delta G equals negative NFE. Delta G equals 3 zincs going to 3Z2N. That is 6 moles of electrons. 96485 coulombs per mole electrons times E, which is 0.0218 joules per coulomb. All right, guys. -6 times 96485 times 0.0218 equals -1.26 times 10 to the 4th joules. Still per mole reaction. I just took that away from it for now, okay? That is delta G. We need K. So now we know rat link, delta G equals -RTLNK. Remember that R here is -8.314 joules per mole Kelvin. So I'm going to keep my delta G in joules. You really have to be mindful of your units. There's no room for error. T, that's what I forgot to plug in. Very last problem. Kelvins, right? So here my kelvins are gone. And then I have natural log of K, and that's what I'm solving for. Okay. This is per mole reaction. Remember, we said this is per mole reaction. So you see that when we divide, both the joules and the moles will go away. And let's go ahead and do that. So I'm going to divide my value here by the product on the right-hand side. I'm going to put in parentheses, -8.314 times 298, close parentheses, equals, I've got 5.09309379 equals the natural log of K. Second natural log, second answer equals K equals 1.63 times 10 to the 2. That's cool. Cool. And that is greater than 1, right? So does that make sense with everything else? Yes, because E cell was positive, right? And delta G was negative. So everything looks good. Good stuff. Watch your units. Watch those units.